Alright, so before we did when the leading coefficient is 1, but now we're going to learn how to factor in quadratic equations where the leading coefficient isn't 1. So instead of finding two numbers that like add and multiply, we need to find four numbers. So I'm going to call them U, V, P, and Q. So we need to find two numbers that multiply to the first term, the first like x squared coefficient. We need to find two terms that multiply to the last term. And finally, we need to find the four numbers should also be satisfying this. So we need this sum, u times q plus p times v, to be equal to the middle term. So let's start with this example, 2x squared minus 5x plus 3. So we need two numbers that multiply to 2. So they're going to probably be 2 and 1. And in general, you don't really want negatives multiplying, especially for u and v. So we're going to keep them positive 2 and positive 1. So in general with this, like I've already kind of applied it there. So it's going to factor as ux plus p times vx plus q. Finally, you can also assume things. You can say u is 2 and v is 1 because in the end it won't matter. You'll just get the factors but in a reverse order. So we're just going to assume u is 2 and v is 1. Now we need to look at 3. So we need two numbers that multiply to 3. This can either be positive 1 and positive 3 or negative 1 and negative 3. So we have to think about that, and we also have to order them differently because we need uq plus pv, so we need 2q plus p to equal negative 5. So after testing out our four cases, which is 1, 3, 3, 1, negative 1, 3, negative 3, negative 1, we can get that q must equal negative 1, p must equal negative 3. So what does that mean? Well, it's ux plus p, so this becomes 2x minus 3, and vx plus q, so x minus 1. And this is our factorization over here. Now let's look at the second one. The second one, first, I noticed that there's a common GCF of 7, so I'm going to factor that out first. So we have 7 times 7x squared minus 8x plus 1. Now we have to factor what's in parentheses. So I look at that, and first we need two numbers that multiply to this leading coefficient of 7. So the only pair that works is 7 and 1. Because again, we don't need negatives. And in fact, like the previous thing, we can assume u is 7, v is 1. Next, we need two numbers that multiply to 1. That can either be 1, 1 or negative 1, negative 1. So in order to figure out which one it is, we're going to have to use this thing. So uq plus pv, that's 7q plus p must equal negative 8. So if you put in negative 1 for that, it works. So it becomes 7x minus 1, x minus 1. And this becomes our factorization.